Hello YouTube viewers, welcome to my show Future Friday. In today's episode, we're gonna take a look at ground effect train, a Hyperloop killer maybe. So let's dive right into it. So what the heck is this ground effect train? All you have to understand is ground effect is a thing that happens of every aircraft once they come close to any solid surface, be it water, as in like it's not gonna move solid in compared to air. So once you come close to it, there is a phenomenon which we call ground effect. Now you can float on top of that, and generally it's a bit of a hassle to deal with for normal aircraft, simply because normal aircraft is built to operate in a high altitude. It cannot utilize ground effect. Heck, it's a problem for them. So but there are certain vehicles that you can build that utilizes that principle, ground effect, to fly directly. Now it's the whole concept of this ground effect train is basically you have aeroplane and you have it on a track. That's it. There is nothing about it. It's just plane on a track. So then question becomes, why the hell bother with this? One simple reason: efficiency. Ground effect induces a lot of drag in normal aircraft. Why? Because aircrafts are not built to extract utility out of it. It's like they have to fight against it so they can work in a higher altitude. So if you use ground effect itself for propelling yourself, there are two core benefits. First, your fuel consumption goes drastically down, like dramatically down. There is no competition here. Then on top of that, your carrying capacity also goes up. So efficiency goes there. And in terms of speed, when I'm talking about trains, this can easily go to 400 to 500 kmph. Now of course you can keep it even slower, like you can keep it 150 or 200 if you want to, and of course your energy consumption will be less and your range will be increased, but you can do that. And on top of that, it's safe. Your plane can fall out of the sky. This is literally few millimeters to few inches above the ground, so it's not gonna fall. Like inherently, even if it loses power, it will slowly, gradually land itself without any intervention from any computer or living creatures. So there are certain unique benefits to this. First being improved mileage. Then of course, compared to other trains that would be fast, it will be almost as same speed as maglev. And then of course it would be safer than air travel, simply not by the fact that a terrorist cannot blow it up or things of that nature. It will be safer inherently, as in there is no point of falling in this. So this is why we even want to consider this. So how the heck this magic works? Now if you want to understand this in simplest term, type Ekranoplan in Google and you will find it. There have been a lot of research in this field. So all you have is ground effect aircraft, and it's moving in what we call its own channel, basically the track. Now track is nothing fancy, it's just U-shaped concrete blocks, nothing magical about it. So how the heck this is working? Now ground effect happens near to the ground. Now that near to the ground does not mean it has to be ground. It has to mean a surface that is more dense than the air. So basically concrete is definitely more dense. So when you put side channels also, when you have like this kind of scenario, the wing, when it gets too close to the surface, like let's say it started to drift and it started to very close to this, the air trapped here will pushes it back. So this creates a self-centering effect. So basically this, unless you deliberately damage it, it will never hit any side. And like if it, let's say for some reason, let's say your airfoil is like a bit unbalanced and it starts to shove it into one direction, the air pressure there will push you back. So by default you cannot crash into anything unless it's either badly designed or damaged. So this is the whole point. This U-shaped track, it's basically simple concrete. This is a plane which is specifically designed to be like a Ekranoplan. There are many designs and philosophies behind this. Now speed, in practical terms, it can go supersonic if you want to, but nobody would encourage that, simply because at that speed ground effect is no longer profitable for you. So it has to be subsonic. It cannot exceed supersonic. And for realistic purpose, 500 kmph is generally classified as like the top. Like you can push it higher than that, but it's at that speed it's not yielding you any significant results. So are there any problem to this magical idea? Now first and foremost problem is power delivery. This is the reason why you don't see it everywhere, even though in principle it's cheaper, simpler in every regard, in every other comparison against it. It's just the power delivery is the mechanism that's stopping us. Basically how you gonna power it? Now you have one simple option. you have onboard fuel, basically whatever, be it battery, be it supercapacitor, be it jet fuel, whatever you have onboard it. Now benefit, the track cost, as in your track would become basically a concrete channel. Generally, because fuel is involved, nobody wants to deal with this. Okay, now other option is track based. Basically you will have some way to leech off electrical power from the track and then power your onboard propellers. That's option number 2. Benefit, your track is a bit more expensive but not ludicrously more expensive. Now third option, it is track propulsion itself. Basically track itself is propelling you like a maglev. Now like, okay, wouldn't that make it as expensive as maglev? Well, no, because maglev have to spend energy in multiple ways. First way is basically levitation, second way is to make sure it's not hitting any side. So here you will only need to do basically propulsion. How can you do that? Roller coaster already do that, linear induction motors can already do that. So it's not magical system. And you want to see linear induction motor in large scale, there are certain metros in this world that utilize something like this right now, as of now, in linear induction motors. So basically this aluminum plate itself is there on tracks, and motors on the track, basically on the train, is using it as a like pushing, basically it's pushing on that. Now in this scenario it will be inverted, so it's basically like a maglev, only a cheaper version of it. That's why nobody even wants to consider this track propulsion. However, this will give you the highest speed and still would be cheaper than a maglev. So what kind of cost we are talking about? Everything is fine and dandy, every idea is fine and dandy. You can check my video about Hyperloop scam there. It's like Hyperloop can be built, undeniably so. Nothing in this says like, oh, Hyperloop is breaking the laws of physics. It's super easy to build. It's just cost of it. When you see the bill of it, it's like, yeah, no, just no. So that's the whole point. Cost matters at the other end, because this is a public project. This is what your taxpayer will pay. So you cannot have a scenario where you're like, okay, only elite people can ride on those. That's not gonna fly. So you have to make sure the cost is low. Now inherently it's cheaper than maglev, even though if you introduce track based propulsion where your track has induction motor, it will need much less of them. Because as you can see, like this is a U channel for synchronization, this one, and as you can see all sides have electromagnets and it's very complex. So compared to this versus a normal Ekranoplan based train, yeah, this is 3 times more expensive. So flat out, compared to maglev, there is no competition. And then track cost compared to what, okay, let's say maglev, nobody is even thinking about it. What about high-speed trains? Now in high-speed trains, that depends. If you have onboard fuel, flat out, this will compare to like, this will become equivalent of free. Like you don't have to worry about it. It's just free. It's like, yeah, concrete. That's it. Nothing fancy about it. So, but if you are comparing it against, let's say, Shinkansen railway line, then yeah, the cost starts to come close. But if you can do power delivery directly to the craft, so it has its own propulsion motors and turbine to provide air pressure. That way the cost goes up, but not as much as like a high-speed rail network. So you still have a scenario where you can easily beat the high-speed railway. So in cost-wise, it's actually very, very feasible. Then we come to the fact, is there a hope for it? Is there a future about this? Well, it is a low hope thing. I will not put my money on this. Well, let's just put it that way. Because it is limited by one core factor. How the heck you're going to deliver the power? If you can deliver the power to it, like wirelessly or on cheap, because be mindful, whenever you are talking about this sort of system, it's not that, okay, it wirelessly delivers power and that's about it. It's like how long of a track you need to deliver power. How much cost per kilometer starts to, because right now, if you just, let's say this has onboard fuel, this is the cheapest means of transport, but nobody wants to do that, like, because then you become reliant on fuel prices. So if there is a way to transfer electrical energy to this, either by supercapacitor or something like that, and it does not take too much infrastructure in terms of cost per kilometer in terms of tracks, tomorrow you're gonna start seeing this, because this has certain advantages. Now, because it is running in a U channel, it's not affected by weather. Basically, you can have of course you will have some turbulence if weather is like a cyclone is going around, but nothing serious. And in terms of weather, there is snow, unless it's like fully snowed in, there is no issue than that. Water, no issue. Leaves, no issue. So there is a lot of hope in this technology, and I have provided the link to a paper down below where they discuss that they are building small scale models and things of that nature. So if we solve the power issue, tomorrow you can start seeing this. So as of now, I will not count this out of the race yet, but that power issue is a big issue. So this was my presentation on ground effect train. I hope you liked it or learned from it. In that case, please leave a like. If you didn't, don't worry about it. You can press dislike, press it twice. Now I would urge you to leave a comment because I reply to all of them. And please subscribe, press the bell icon if you're free, and as always, thanks for watching.